Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So we have an original amount, and this represents 100% of the original amount. The new price, or new amount, represents 113% because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13. And we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table. So it'd be 10, 20, 30, and 15 times table with 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time. And all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. It's really important when answering this question that we're really methodical. So, we're going to start off just looking at steak, and I'm going to start off with the S, and we're going to pair it with the first dessert, which is the I. Then we're going to pair the steak with the second dessert, which is the mousse. Then we're going to pair it with the third dessert, which is the fruit. So we're being really methodical. We've done all of the combinations with steak, and so we're going to look at burger next, and we're going to pair it with the first ice cream, then burger, and we're going to pair it with the mousse, and then finally the burger we're going to pair with the fruit. As long as we do things methodically, we don't ever miss any. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chelton, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chelton to Devley is 34 miles. Distance from Devley to Bovlow is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chelton at 9 o'clock. He drives from Chelton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolcoed to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed, distance, time triangle. So speed equals distance over time. And we're covering up the time, because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. The question asks us to find the bearing of Adrift from Billstown. So we're at Billstown and we're looking at the bearing of Adrift from it. So we're looking at this angle here. And so to find that angle, all we need to do is 360 degrees, which is angle at a point, and then take away the 39 degrees that we know, and that equals 321 degrees. And the reason why we find this angle is that all bearings are from north going clockwise. So the answer is 321. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth, how many students are in one part. One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. To see if a number's in a sequence, we get the nth term and we get it equal to the number we think is in the sequence. And if the number is in the sequence, then we'll get a integer for n. If the number's not in the sequence, then we'll get a decimal. So we're just solving this now, and we're doing 135 take away 24, which is 111. And then we're going to divide both sides by 10, and you're probably already seeing the fact that it doesn't work exactly because n is 11.1, which means that Prisha is wrong. 135 can't be in that sequence. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't, so we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082, and that would be centimetres cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimetres cubed. Times that by the 5,082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000 and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6991000. And obviously, if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got 2 sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all, add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also 2 parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. First thing I'm going to do is add these column vectors. So we're going to add the tops first. And then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4. And 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. And I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labeling it. So BC is the hypotenuse. The opposite here and adjacent here. We're not using the adjacent, so we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two, so it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in. And we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29. And we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that on the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90 take away 79, and that's going to be 11. So we know this is 11 degrees here, and we have enough information now to work out CE because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. To find the interquartile range from a cumulative frequency graph, you first of all see what the graph goes up to. Here you can see it goes up to 20. And what we do is we halve that, and that's the value we use to find the median. So we halve that again, and that's the value we find for the lower quartile, which will be 5. Then you add the 5 to the 10, so the number we use for the lower quartile to the number we use for the median, and we get 15. So those are the 2 points there that we'll find our quartiles. So we draw a line across to find our lower quartile, a line across and down. And I think that is roughly, I think 22 roughly. We do the same again for our upper quartile. Line across and down. And that's roughly, I mean, these are going up in 4s, so maybe 37. Because this line here would be 36, that would be 37. So to find the interquartile range, it is interquartile range, let's do the formula, is the upper quartile, take away the lower quartile. Upper quartile is 37, lower quartile we said is 22. And so 37 take away 22 is going to be 15. Now if you've got slightly different values, that's absolutely fine. The exam will always give a bit of leeway, especially when reading off graphs. So there are two things with this question. There's the negative power and there's the half. And we're going to deal with them separately. So to deal with a negative power, all you need to do is put the whole thing over 1, or 1 over the whole thing I should say. And it's nothing more complicated than that. We just copy the same thing again, but this time instead of it being negative a half, it's just to the power of a half. So that's dealt with the negative. Now to the power of a half means square root. So whenever you see anything to the power of a half, it just means square root. So let's deal with the 16 and the x to the power of 16 separately. Now with the 16, we're going to square root it because to the power of a half just means square root. So square root of 16 is 4. Now with the x to the power of 16, there is another rule in indices that say if you've got a power on the inside and a power of the outside, you just multiply them together. So 16 times a half is 8. So the answer will be 1 over 4x to the power of 8. So sometimes it's easier just to do a quick diagram to see what's going on. So I'm going to say that the house is here and the shop is here. And so this person is walking to the shop and then they walk back from the shop, but they don't walk as much. And we're looking to see the maximum distance the person is from their house. So we're looking to maximize this distance here. So we want this distance to be the biggest it can be. So we can see that we want to maximize this distance here, so that the shop is a long way away. And we want to minimize this distance here because we don't want them to have made that much distance towards their house because we want to maximize that distance. So we're going to find the maximum for the 3,750. So it's to the nearest 10. And a trick you can do to find out what the upper bound is going to be is just half the accuracy. So 10 meters to the nearest 10, half of that would be 5. And then just add that on. So that's going to be 3, 6, 5, 5. That's the upper limit. We want to minimize this distance, which is 120. So the accuracy is still 10 because it says both measurements are to the nearest 10 meters. So we're going to halve the accuracy. 10 would be 5. And this time we're going to take it away. So 120 take away 5 would be 115. Okay, so to find the maximum distance the person is from their house, we're just going to do 3,655 take away 115, which will equal 3,540. Okay, so we're asked to find length AB, which is this length here. But I'm going to start just by renaming these letters, and I'm going to put this as a capital C, and this as a capital A, and a lowercase a over here. And the reason it being is that we're going to use this formula, which is area equals half AB sine C. And you can see that the angle C is a C in this formula, and so I've just changed it to a C here. And so we're looking for little a. We're not interested in little c or big B or big A. We're focused on, and we've got a little b here, we're focused on little b, little a, and big C. The area is given to us in the question is 21.6. And we're looking for A, but B is 5 and C is 68. And so all we need to do here is rearrange all of this. And we're going to start just by working out what half times 5 times sine 68 is. And that's going to be 2.317 blah blah blah. That's times A. And then we're going to do a bit of solving, because if we divide both sides by that 2.317 blah blah blah, that'll give us what A is. So when we do that, we get 9.318 blah 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 equals A. So rounded to 2 decimal places, that's going to be 2.32. To find the distance or displacement on a velocity time graph, we're actually going to find the area underneath the graph. And to do that, we're going to split the graph into two. And we've got the trapezium on the left-hand side, and we've got this rectangle on the right-hand side. So to work out the area of the trapezium, we're going to do half A plus B times the height. And the two parallel sides are on the left and the right. So it's going to be half times this part here, which is 40, plus this point here, which is 160. And then the height is actually the width. So the height is this bit here, so it's going to be times 2. Those will cancel out, the half and the times 2, so that would be 200. And similarly, to work out the area of B, it's just length, width times length. So that's going to be 3 wide, and again 160 tall. So 3 times 160, which would be 480. And so we need to work out the total area. And we do that just by adding the two together. So 200 plus 480, which will be 680. We can write the equation of any linear graph as y equals mx plus c. So m is the gradient and c is the y-intercept. So we've got to find what the gradient and the y-intercept are. Well, I'm going to first of all try and figure out what the gradient is, because we're actually given some clues here. We're told that the line is perpendicular to the equation given. Now I'm going to rewrite this a little bit just to make it a bit clearer what the gradient of this is. So I'm going to write this as minus 1 over 12. I'm just going to leave a bit more of a gap there. Minus 1 over 12 x plus 12. And you can see that the number before the x, the coefficient of the x, is minus 1 over 12. But we're not told that it's parallel to that, so it's not, the equation that we've got is not going to have the gradient as minus 1 over 12. We're told it's perpendicular. Now, when two things are perpendicular, to find the gradient of the other one, if we know one of them, you've got to change the sign and find the reciprocal of the fraction. So to find r gradient, we're going to change the sign, so it's negative, so r gradient is going to be positive, and we're going to flip it. We're going to find the reciprocal. Reciprocal of 1 over 12 will be 12 over 1, or just 12. So the gradient of our line is going to be 12. To find the y-intercept, we're going to use the points given to us. So we've got x equals 3 and y equals 4 for a point on our line. We're going to substitute those into the equation we've got. So it's going to be 40 equals 12 times 3 plus c. Put in our solving lines. 12 times 3 is 36. And we're going to take away that 36 both sides. So it's going to be 4 equals c, or c equals 4. So our equation will be y equals 12x plus 4. Going to start off by labelling the triangle, and so we've got capital A here, capital B, capital C, and lowercase a, lowercase b, and lowercase c. It doesn't actually matter which way around B and C are, but capital A is always the angle that we're given. So we've got to work out whether we're using cosine rule, sine rule, or something else. Well, here we're given 3 lengths. Well, actually one of them is unknown, but there's 3 lengths involved and an angle, so that's definitely going to be cosine rule. So we're going to write out the cosine rule for when we've got a length, which is the one that starts with a squared. So it's a squared equals b squared plus c squared minus 2bc cos a. And let's fill in the numbers we've got. So that's going to be 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 22. And when you type that into the calculator, you get 6.184 blah blah blah. But that's what a squared is, so what we need to do now is just quickly solve that by square rooting both sides. And so we get a equals 2.486 blah blah blah. It says it wants its 2 decimal places, so that's going to be 2.49. So the first thing to notice with this question is we've got an isosceles triangle between O, B and A, because these are both radii. And so what we can do is we can find this length here, or this angle here, by doing 180, take away the 40, which equals 140 degrees. And because it's an isosceles, we do 140 divided by 2, which is 70 degrees. So we know this is going to be 70 degrees here. And whenever you write down working out like this, so the first one would be 180 take away 40, you need to write down y, so you put in brackets angles in a triangle. And then the second one, you would put in brackets isosceles triangle. That's why that's 70, that's why we halve the 140. Okay, so the big thing here is that we can now work out what this angle is. This angle is the 10 degrees plus the 70 degrees, which is 80 degrees. And we use a circle theorem here called the alternate segment theorem. And what the alternate segment theorem states is if you've got a tangent and you have a triangle coming off it, which we do here, then the angles here and here will be equal, and also the angles here and here will be equal. It's basically the angle between the triangle and the tangent and the opposite side of the triangle. An alternate segment theorem is quite hard to spot sometimes. So we know that x is going to be 80 because it's going to be equal to the angle at CBA. And what we must write down is alternate segment theorem. You must have those 3 words written down, and it's crucial that you write them down in that order, and you don't call it an alternate segment or a segment theorem. It has to be those three words. And in all mark schemes, it will have those three words written down. And normally there's a mark for a non-circle theorem proof, so angles in a triangle or angles in an isosceles, or both of them for this question. And then a mark for the circle theorem itself. So make sure you write down all the reasons. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA. And we could have OW or WO. Now, what we notice really when we do this is that OA gives us the same probability as AO. Same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27, and then 12 over 26, and so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator, so 468 over 702. That cancels down to 2/3, so there is a 2/3 chance that the drinks will be different. So we're going to start by labelling the sides here. So we've got capital A up here, little a down here. It doesn't matter which one you label. Capital B here, little b here, and capital C here, little c here. So you notice the C's aren't really involved at all, but we've got the two A's, we've got the capital A and the lowercase a, and we've got the capital B and the lowercase b as part of the question. And so when you've got a pair or two pairs of angle and sides, you are going to be using the sine rule. And so the sine rule says that sine capital A over lowercase a is equal to sine capital B over lowercase b. Now you might be wondering why I've put sine A and sine B at the top, when sometimes this is written as the lowercase a and lowercase b at the top. Well, if we're looking for the angle, which we are here, we're looking for capital A, you put the angles at the top. If you're looking for the length, you put the lengths at the top. Okay, so we're going to fill this in. So sine, we're just going to leave that as sine A, because it's just, or sine x actually, shouldn't it be? Sine x over, and then lowercase a is 6, equals sine B, the angle is 35, over lowercase b, which is 7. Okay, we're going to work out what the right hand side is. So that's going to be 0.081 blah blah blah. And then we're going to be solving this. And the first thing we're going to do is times by 6 both sides. So we get sine x is equal to 0.491 blah blah blah. And then we're going to inverse sine both sides. And so we have x equals 29.448 blah blah blah. And our answer wants to be rounded to 2 decimal places, so we're going to put our answer as 29.45 degrees. So we're going to first of all work out how many squares there are in total in this diagram. And so we can count that there's 12 in the first group. There's 2, because there's 4 halves, which are 2 in the next one, and then there's 4 in the last one. So the total is 12 plus 2 plus 4, should be 18 squares. Next we're going to work out how many there are that are less than 25. So 25 is here, so there's 1.5 there, and there's the 12 we've got here. So it's 12 plus 1.5, should be 13.5. And to work out a proportion, we just write it as a fraction. So the 13.5 over the total amount, which is 18. And we can write that as a decimal, which will be 0.75, so it would just be 3/4. So we know the cuboids are similar, so there's going to be scale factors. And we're given the 2 surface areas, so we're going to first of all start there. And we know that there's going to be a scale factor between them. So what do we times the 9 by to get to the 272.25? So we're going to do 272.25, the big one divided by the small one, to find out what the area scale factor is. And when we do that, we get 30.25. So the area scale factor is 30.25. Now this question is all about volume. But we're going to work a little bit backwards, and we'll find out that the area scale factor is the linear scale factor squared. So we're going to work out what the linear scale factor is. So to find the linear scale factor, we're just going to square root the 30.25, the area scale factor. And when we do that, we get the answer of 9. So square root, 5.5 even. Didn't sound right. Okay, so when we square root that, we get 5.5. Now, we know that the volume scale factor is equal to the linear scale factor cubed, because there's 3 dimensions. So we know it's going to equal 5.5 cubed. And so the volume scale factor is going to be 166.375. Okay, so that's the volume scale factor. Now we're given the larger cuboid has a volume of 8984.25, and we're looking for the volume of the smaller one. So with scale factors, to get from the smaller to the bigger, we times it. To go the other way, we just divide. So we're going to divide this by 166.375. And then when we do 8,984.25 divided by the volume scale factor, 166.3275, we get the answer of 54. With this question, we're going to first of all have to find a length before we can find the length AF. And it does involve us thinking in 3D. What I find sometimes useful, though, is to draw kind of a 2D representation of the 3D. So I'm going to look at this triangle here, and I'm going to notice that I need to find length BF. That's going to be my objective at the start of this. So I'm just going to draw out this triangle again, but in 2D just to make it a bit easier. And BF is this length here, this is 6, and then this is 9. So we're going to use Pythagoras, so it will be sort of A squared plus B squared equals c squared, so it would be 6 squared plus 9 squared equals bf squared. 6 squared plus 9 squared is 117. And then we just get our solving bit in, just to square root both sides. And I can leave this as square root 117 for now. Okay, the actual length that we want is AF, which is this one here. And I'm going to create the right angle triangle using this bit here. So let's just draw that out. Now the top bit is AB, which is the same as the bottom. It's going to be 14. It's going to be the same as EF. Then the BF we've just found is root 117, and we're looking for AF. And this is the right angle. I didn't show the right angle on the other one, but it should be there. Okay, so we're going to use our a squared plus b squared equals c squared. And a squared is 14 squared plus square root of 117 squared equals AF squared. So 14 squared is going to be 196. Now root 117 squared is just going to get rid of the square root, so it's just going to be 117. And when you add them together you get 313. And again get our solving lines in. Square root both sides. And this time we're actually going to square root 313 because we need a decimal answer. So it would be 17.691 blah blah blah. It's equal to AF. And it says to 2 decimal places, so that's going to be 17.69 centimetres. I'm going to first of all just focus on this rectangle here. And we know that to find the area of a rectangle you multiply the two lengths. And when you've multiplied them for this rectangle we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A, we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So first thing I'm going to do is I'm going to put my lines in because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30 so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side because that gets rid of the denominator. And it will be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I am going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1870x plus, was it 56,100? I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1870, and we're going to take that away from both sides. So take away 1870x from both sides. and that will leave 5,100x on the left hand side, and then obviously we've got the 56,100 on the right hand side, and we want to get rid of the 5,100, so we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So a is 17. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x. So half of the 10 would be 5. Close bracket, squared. Now I'm going to leave that half done because down here I'm just going to, well, across here, I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5, x minus 5. So we get x squared minus 10x plus 25. So notice here, it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. Going to leave the 3 on the outside of the x. In fact, let's keep the colour scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now the m part is going to be 3, the p part inside the bracket is going to be minus 5, and the q part is going to be minus 86. A simple trick when you're finding the inverse of a function is to replace or to switch the y and the x. Now we don't actually have a y in here, but we can just put one in, it's not a problem. So we can just rewrite this function as y equals x over 10 minus 11. And we're just going to switch around the y and the x. So x equals y over 10 minus 11. Now, the objective now is to get the y on its own, to make y the subject. So we're going to first of all add the 11 both sides. And I've made an amateur move here. I've not left myself enough room, so let's just scoot that across. Okay, so add the 11, so it would be x plus 11 equals y over 10. Next thing we're going to do is multiply by the 10 to get y on its own. So it would be 10 brackets x plus 11 equals y. Expand those would be 10x plus 110 equals y. Now this doesn't equal y. We are looking for the inverse function with this notation here. So we just replace the y with this notation and we get 10x plus 110. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top. Then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5. And the radius for the larger cone is 20 and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975, blah, blah, blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah, blah, blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah, blah, blah. And to 2 decimal places, it's going to be 10,388.20. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.